So now we're going to look at a more complicated version of the last topic, where we're solving the inequalities in one variable, but this time we're going to introduce fractions and radicals. So sometimes they're going to ask you to find the zeros, and you have to know that that comes only from the x values that make the numerator 0. So whenever they ask you for a real 0, set the top of the fraction equal to 0 and solve for x. When they ask for where the rational expression is undefined, there are two things to look for. The first one is if you have a fraction, you need to identify any x values that make the denominator equal to 0, or if you have a radical, you need to say whatever makes the inside of that radical negative. Those would be the two situations you'll be looking for to make the expression undefined. Then you'll still make a sign chart by plotting out the solutions and the undefined x values, and you'll plug in test values to see where the graph is positive or negative in case they also ask you for where the function is greater than 0 or less than 0 as well. So here's an example similar to what you'll have in your assignment. First, they want us to figure out where is this r of x function equal to 0. So for that part, we're only going to be looking at the numerator. So if I say when does x plus 1 equal 0, and then solve the equation, we have it -1. That's our answer for when this equals 0. Next, they ask us for when is the function undefined. So for the undefined values, now I need to see what makes the bottom of the fraction, and only the bottom, equal to 0. So I'm going to set both x plus 3 and x minus 1 equal to 0. So in this case, my solutions will be -3 and +1. To determine both the positive and the negative intervals of the function, this is what we're going to make our number line for, our sign chart, and we'll have all of the numbers we identified earlier. So -3, -1, and +1, all of them will get marked on the number line, and then we're going to plug in test values like -4, for example. If you plug in -4, you're going to have a negative on top over a negative times a negative. So a negative times a negative is positive, and then if you have a negative divided by a positive, it's negative. Next, I would plug in a number like -2 in between -3 and -1. If you're plugging in -2, you're going to have a negative on top, and then on the bottom, you're going to have a positive times a negative. Well, a positive times a negative is negative, and a negative divided by a negative is positive. Next, I'm going to plug in a number in between -1 and 1, so 0 is a good choice whenever that's an option. If you're plugging in 0, that gives you a positive on top, and in the bottom spots, you're going to have a positive and a negative. Again, a positive times a negative is negative, and a positive divided by a negative is negative. Last one, we need to plug in a number from this last section, so I'm going to use +2. If you're plugging in 2, that gives you a plus on top, and in the bottom you get a plus and a plus. So positive times positive is positive, and positive divided by positive is positive. So now if they say where is the graph positive, I need to specify that it's positive for all of the values of x between -3, -1, and all the values bigger than 1, so from 1 to infinity. For the regions where the graph is negative, we have all the numbers less than -3, so from -infinity to -3, and we have the numbers between -1 and 1. So those are our four answers. Where is the graph 0? At x equals -1. Where is the graph undefined? At x equals -3 and at x equals 1. And then where is the graph positive and negative? These are the positive values and these are the negative values. Now we're going to do something similar, but this time we're going to have a square root in our expression. So first we'll find what causes the f of x value to be equal to 0. So I can set each of these factors equal to 0 separately. And the same thing inside of the radical, you can actually ignore the radical itself because we just want to make x plus 1 equal to 0, because then the square root of 0 will still be 0. So we can ignore the radical part. And then if you solve each of these, we find that it equals 0 at +2 and at -1. So those are the solutions for where the function equals 0. Now to find where the graph is undefined, I don't have any fractions in this one, but I do instead have a radical. So we need to say what makes the inside of the radical less than 0, because that's what's undefined for us. It's whenever the inside of a radical comes out to be a negative number, which in math terms we say is less than 0. So if you subtract 1 from both sides, the problem is anytime x is less than -1. It can equal -1, that's fine. In fact, we specifically said when it equals -1 that that's a 0 of the function, but it's undefined once you go past that point. And then lastly, we're going to look at the positive and negative sections of the graph. So again, I need to break the number line into pieces using the zeros and the undefined values if there are any applicable ones for the function. In this case, the only actual critical numbers, we call them, are 2 and -1. Now everything beyond -1 is going to come up undefined, because if I try to plug in something like -2, I end up with a negative inside of the radical. So this whole section is undefined. That means it will not be listed for any of the positive or negative values. And then I plug in a number in between -1 and 2, like 0. If you're plugging in 0, you get a negative and then a positive. And when you multiply a negative times a positive, that answer is negative. Next, we'll plug in a number to the right of 2, like 3. If you're plugging in 3, this will be a positive times a positive, which comes out as a positive value. So now I can say that the positive sections of the graph are all of the values that are greater than 2, but not including 2. Otherwise, I would need to use a bracket. And the negative values are all of the values in between -1 and 2. But again, we're not including those endpoints. We could have also expressed the undefined values as an interval instead. So let me go back and show you that if they needed an interval notation, we just would have said it's all the values from -infinity up to -1. That would have been another perfectly fine way to specify where is the graph undefined instead. So that's it for the assignment. Hopefully that'll help you guys get through the textbook work you guys will be doing in class. Thank you.